So for this week's presentation, we're going to be talking about the African plate. So we're going to be talking about the crust first. The crust is mostly oceanic, but also includes continental crust as well. This plate straddles the equator and the prime meridian, so it is a very major tectonic plate. The African crust includes old crust with deep roots in the subcontinental lithosphere mantle. Other plates near the African plate. So the African plate is right here. This is the border of it. It looks like a big Africa, pretty much. So bordering the African plate, we have the Eurasian plate, which is the borders right here. This is where they connect. We have the Arabian plate. This is where they border up right here. We have the Indian plate. This is where they touch borders. The Australian plate. They touch just a little bit right here. Then we have the Antarctic plate, which touches a lot of that. It also touches the South American plate, which is this long border right here. And it touches a little bit of the North American plate right here. Movement. Africa has three divergent boundaries since South Africa, India, and Australia have split away from Africa. The African plate has divergent and transform plate movements. So divergent plate movements is when the plates move away from each other. And if you look at the arrows on the map, you can see that these plates are moving away from each other. Right here, right here, right here, and right here. What transformative plates movement is they don't squish up against each other. They don't move apart. They just rub back and forth on each other. And this makes a lot of sense that most of the boundaries are divergent is because Africa used to be the center of Pangaea, and Pangaea was the supercontinent at one point where all these land masses were once all together, but they've moved away, and it makes sense because Africa was pretty much the center of it, and all of its boundaries are divergent, and it makes sense because it pushed all those land masses back into their own spots. How fast does it move? So the speed of the African plate is estimated to move around 2.15 centimeters per year. Well, that doesn't seem like a lot in our lifetime. It really isn't a lot. But if you think about over 100 million years, that's a long distance for that big of a mass to move. So over the last 100 million years, scientists have said that it's been moving in a northern direction. Plates move from anywhere from 1 to 20 centimeters per year, and it varies from all different plates. Year, um, the fastest ones being the Pacific, Nazca, Cocoa, and Indian plates. For example, the Indian plate moves about 3.4 centimeters per year, where the African plate again only moves around 1.5 centimeters per year. So that plate moves probably like 2.5 times more per year than the African plate does. So the African plate technically is a little slower than most of the other plates are. How do we know these things are true? So if you look at a seismology chart, when you, when we look at the African plate, we see that all the dots on there are red. This means that all of the earthquakes are between 0 and 30 kilometers. And we know that divergent and transformative plate movement, the earthquakes are around that depth. So that gives us a good idea that hey, it might It's probably a divergent or transformative plate movement. When we look at a volcanology map, we see that there are a lot of volcanoes in the borders of the plate. And this is because in divergent movement, the plates are moving apart, and this opens up for volcanic matter to come up into the ocean. But really, it doesn't. Most of the time, it doesn't go anywhere, and all it does is cool, and it turns into more earth, and it just fills the holes. When we look at a seafloor edge, we look at and we'll see that most of the border of the African plate is red, and in the graph, red meant that it was newer. And that makes sense because the lava is constantly making new seafloor. So that when we look at that, we know that when it's red, that it's an active plate. Looking at a geography map, we see that there's a clear outline of the African plate because of the constant divergent movement and volcanic activity in the seafloor. You can see an outline of where the new material in the plates are at. Again, thanks for watching.